Hi, I'm Terry VanNoy. Thanks for watching. This is a video from my online classroom, Math Class with Terry V. Every once in a while I'll do a video like this that's a viewer challenge, and it's either a question sent in by one of my viewers or something I create to sort of challenge you, stretch you a little bit, maybe review something in a video series. We're going to be talking about solving non-right triangles, and in this case it's another tool called the law of cosines. Alright, let's see when you use the law of cosines and what that actually is. Alright, here it is. First of all, let's look at this triangle. As always with these videos, we're going to use a standard naming procedure, and that's capital letters for the angles and lowercase letters for these sides. Notice that angle A has an opposite side, little a. Okay, so we want to make sure we're consistent with that. Now the law of cosines is this big ugly formula looking like that. Now the first part of it looks kind of like the Pythagorean theorem with a squared, b squared, c squared. But notice how if you're going to look for a missing side, which if in this example would be a, alright, you're going to have b squared plus c squared minus 2bc cosine a. Alright, now that all comes from a formula that I'll have to derive for you in some other video. But here is the pattern I want you to notice. If you're going to be looking for a, notice how at the other side it's going to be cosine a. And of course that's why we call it law of cosines. Now everything else is the b and the c. Alright? You just have to kind of, memorize this, work with it a little bit, practice a little bit, and you'll get the pattern. Now if I knew side a and maybe I was looking for side b, then I would have b squared right there. And then this would become a squared, c squared, and ac right there. Alright, now again, if I have b here, looking for b, which is b squared in the formula, this would be cosine b. So that's kind of the pattern I want you to notice. And the other thing I want to tell you is that instead of using law of sines, what you need to do is figure out what kind of information is given in the triangle. Now, there's two cases where you'll use the law of cosines. That is, if all you're given is the length of the three sides, A, B, and C, and you need to start to figure out what the angles are, that would be law of cosines. Now it's going to take you 2 steps, but that's how you would do it. And the other, more common way is that you need to know one angle and 2 sides. Okay? In other words, it's going to be side, angle, side. If you know 2 sides of the triangle and its included angle, then you use the law of cosines. Alright, you have to know at least 2 sides of the triangle in order to solve all the missing parts. Alright, I'm going to have you try one example as a challenge, so grab a piece of paper and calculator, and here we go. Alright, we're going to look at number 2 here because it has the most space around it and where I can write. And again, I want you to pause the video and notice how you were given the 3 sides A, B, and C. You're going to have to find the 3 angles. Alright, good luck. Draw yourself a picture. Alright, I've put all my known lengths of the angle sides here, or the triangle sides here, 12, 10, and 15. And notice how I labeled them. And yeah, we're going to have to look for angle A, angle B, and angle C. So let's go ahead and just choose. I'll go in alphabetical order. I'm going to first look for angle A there. And so I'm going to use the little a version of the law of cosines. It looks like this. A squared equals b squared plus c squared minus 2bc times cosine A. Alright, now I know what A, B, and C are here, but I don't know capital A sides of the angle. Alright, so let's go ahead and plug in what we know. So a squared would be 10 squared, which is 100. B squared is 15 squared, which is 225. C squared, of course, would be 12 squared, 144. And then it's negative 2 times 12 times 15 and times cosine A. Alright, let's simplify this down and start looking for A. Alright, at this point we are going to subtract 369 from each side. Negative 269 equals negative 360 cosine A. Now, of course, we're trying to focus on finding angle A, so let's go ahead and divide out that negative 360 from each side. All right, and you'll see what happens here. Don't be worried about the negatives because they actually do cancel out here in this step. So now it's cosine A equals 0.7472, and again, notice that it's a positive amount. So I divide this fraction out to get this rounded to 4 decimal places. Now, that's what the cosine value of A is. To find what angle A actually is, the measure of angle A, now I use the inverse cosine, don't I? So that's going to be cosine, and the symbol is -1. That's inverse cosine or arc cosine of that decimal value. And that's going to be, let's bring in the calculator. So input that value, 0.7472, and look for cosine -1. I have the cosine key here, but I don't have the arc cosine or inverse cosine. Now in this calculator, this Mac calculator, I do have to hit the shift button, and now I get the inverse cosine key there. So you have to check your calculator to see where it is. It's either a second function or a shift of some kind or an inverse. But that's going to give me my actual angle that gives me that degree. So that is 41.65. Let's call it 41.7. There we go. Angle A, 41.7 degrees. Now at this point, and I'm going to go ahead and write that in, 41.7. At this point, I do know angle A and its opposite side 10, and I can actually go to the law of sines now. If you've seen my other videos, you'll know how to do that. But I'm going to go ahead for the purposes of this video, and because we're practicing the law of cosines, which admittedly is kind of challenging and long, let's go ahead and find the law of cosines to find angle B, and then finding angle C will be really simple. This is the formula I'm going to use. B squared equals A squared plus C squared minus 2AC cosine B. Now remember, the reason for that, using that version of the law of cosines, is because we need to find capital letter B. That's the measure of angle B. And so I'm going to make it use, I'll call it the B version of the formula. So let's plug in what we know. So hopefully you can follow my steps here. Now at this point I'm going to subtract 244 to get that constant from the right side to the left side. And again, don't worry about the negatives. You'll see how it works out here. Negative 19 equals negative 240 cosine B. We want cosine B by itself, so we're going to divide each side by the negative 240. That becomes a positive value, which is 0.0792. Now again, that's rounded to 4 decimal places. Now that's what cosine B is. To find angle B, as before, I'm going to look for the inverse cosine. So here's how it's written. Cosine minus 1, or inverse cosine, of 0.0792. All right, let's get the calculator in here and work this out. All right, input the value, 0.0792, and look for cosine minus 1. If you don't see it, look for the shift, inverse, or second function key. There it is, cosine minus 1. What angle gives us that value? 85.457. Let's call it 85.5. All right, angle B written in my diagram right there. Now to find angle C, yes, you could use the law of cosines again, but look for the easiest way. How about all three angles add up to 180 degrees? So let's add these two together and subtract from 180. Total of 127.2. Let's subtract that from 180 and get our answer for angle C. 52.8 degrees. 52.8 degrees. All right, now that's given all three sides. I have to use the law of cosine twice to find the missing angles. Okay, that's actually the most challenging version of solving non-right triangles. All right, again, I hope it's a good challenge for you. I hope you tried it, and thanks for any feedback and comments you send me. Have a great day.